Hello everyone. My name is Mohammad Faisal Niaz and I'm working as an Assistant Director in Road Asset Management Systems CNW Punjab. This presentation serves as a technical introduction to the fast falling weight deflectometer, commonly referred to as FFWD. The objective of this video is to provide a foundational overview of the FFWD system, its operational principles, and its significance in pavement structural analysis. The FFWD is a highly sophisticated piece of non-destructive testing equipment. The term non-destructive is critical as it allows us to assess the in situ structural condition of a pavement without causing any damage to the asset. The primary function of FFWD is to simulate the effect of a heavy moving wheel load. By applying a controlled dynamic load, we can accurately measure the pavement's structural response. The data acquired is a fundamental requirement for analytically based pavement design and management methods. This capability allows engineers to move beyond empirical assumptions and facilitate informed, data-driven decisions regarding pavement maintenance and rehabilitation strategies. The operating principle of the FMWD is based on a transient impulse load and response measurement. First, a predetermined mass is raised to a specific height and dropped onto a series of rubber buffers. This action generates a load pulse that is transmitted to the pavement surface through a steel loading plate. The resulting impact is essentially half-sine-shaped load of 25 to 30 milliseconds in duration, which closely approximates the effect of a moving wheel load. This impact induces a transient vertical displacement on the pavement surface, forming what is known as a deflection basin. To quantify this response, a series of seismic detectors, also known as geophones, are positioned at specified intervals from the center of the load. These high-precision instruments measure the vertical pavement deflection with an accuracy of microns. The shape and amplitude of this deflection basin are directly correlated to the structural properties of the pavement system. From this data, it is possible to determine the stiffness or elastic moduli of all the individual structural layers, which is the primary objective of the test. The Dynatest fast falling weight deflectometer test system is comprised of two primary subsystems, the trailer unit and the in-vehicle control equipment. First, the trailer unit, which is the operational core of the system. It consists of several key elements. A subunit, which contains the electric motor, lifting spindle, the drop weight package, the load cell, and the center geophone holder. Two electronics cabinets, which house the powering, motor control, system control, and the data acquisition electronics. The trailer frame itself, which includes the wheels, brakes, and rear lights. And finally, a raised lower bar, which holds up to 14 geophone holders for precise deflection basin measurements. The second component is the in-vehicle equipment, which serves as the operator's control interface. This includes a laptop computer running the Dynatest data collection software, which manages the entire testing process. A park signal TX unit is also installed as a safety feature to protect against driving while the loading plate is lowered. The FFWD system possesses several key features and performance specifications that establish it as a premier tool for pavement evaluation. Number one is its speed. The system is engineered for high-speed data acquisition. A typical three-drop testing sequence at a single measurement point can be performed in less than 15 seconds. This allows for highly efficient network-level surveys. Second is its accuracy and reproducibility. The system measures deflection with an absolute accuracy of greater than 2% plus minus 2 microns. The applied load is measured with an accuracy of greater than 2% plus or minus 0.3 kilonewtons. Furthermore, the reproducibility of the consecutive test on the same point is typically within 1%, ensuring high quality, consistent data. Third, it provides realistic loading. The system generates a peak load range from approximately 4 to 120 kilonewtons, closely approximating the effect of real-world heavy wheel loads. Finally, operational safety and efficiency are paramount. The entire system is designed for automatic remote-controlled operation by a single person, typically the driver of the vehicle. The data generated by the FFWD has a range of applications in the field of pavement engineering. Its primary use is in pavement management. The FFWD allows us for the evaluation of in situ elastic moduli or stiffness of all structural layers in an existing pavement. This information is fundamental for assessing the current structural capacity of the road network. It is also integral to rehabilitation and overlay design. The calculated layer moduli are used in software programs like LMOD to determine a pavement's remaining service life and to execute the structural design of necessary overlays. Another key application is quality assurance for new construction. FFWD is used to verify that newly built pavements meet their required structural design specifications before they are open to traffic. Lastly, it is a vital tool for forensic investigations and research, used for non-destructive testing of both highway and airfield pavements to investigate premature failures and to support research into new materials and designs. The primary output from each FFWD test consists of the peak load applied and the corresponding peak deflection measurements from each geophone. This raw data is typically stored in a Microsoft Access database format, though other formats are also supported. This deflection basin data serves as the input for subsequent analysis. The data is processed using specialized software such as Dynatest's LMOD program, which is an acronym for Evaluation of Layer Moduli and Overlay Design. Through a process known as back calculation, this software computes the in situ stiffness or elastic moduli of each individual pavement layer. The results of this analysis are then used to calculate the remaining service life of the pavement and to design any necessary structural overlays or rehabilitation measures. The process for conducting a test at a single location is both efficient and highly automated. From the safety of the vehicle, the operator initiates the test sequence using the control software. The system automatically loads the loading plate and the geophone bar onto the pavement surface. It then executes the predefined sequence of drops, which may involve varying drop heights to capture the pavement's response at different load levels. Upon completion, the loading plate is raised back to its transport position, and the operator is signaled that it is safe to proceed to the next test point. As all this data is collected, the system performs several automated validity checks in real time to ensure data integrity. These include a decrease check, which verifies that deflections decrease as the distance from the load increases, flagging irregularities in the pavement or sensor readings. Second is the roll-off check, ensuring that the deflection signals return towards zero correctly after the load pulse, which can identify unstable sensor conditions. And an overflow check, which alerts the operator if any deflection measurement exceeds the sensor's physical range. These integrated quality assurance features provide a high degree of confidence in the final data set. There are several takeaways from this presentation. Firstly, the FFWD is a vital and non-destructive tool for the structural evaluation of pavement systems. Second, its operational principle is to apply a controlled, simulated V-load and precisely measure the resulting pavement deflection with a series of geophones. And third, it delivers rapid, accurate, and reproducible data that is fundamental to modern pavement management, effective rehabilitation design, and robust quality assurance. A thorough understanding of these principles is the first step towards using this advanced technology to its full potential for managing our infrastructure. This concludes the presentation on fast falling weight deflectometer, also known as FFWD. For further information, please contact the Directorate of Road Asset Management System via the provided email. You can also ask questions in the comment section of the video. Thank you.